All right, recording started. Oh, that's right. My watch. It's gonna clang on the table. All right, here we go. So we're talking about logarithmic functions. We shortchanged that to just log, okay? Logarithmic functions is the inverse of the exponential functions. Okay. So let's find the inverse of the exponential function. Exponential function you guys had was y is equal to b raised to the x. Is that correct? So how do we find the inverse? Switch to x and y and solve for y again, right? Okay. So if I was to find the inverse, I would switch to x and y, and then I have to solve for y again. And then, of course, this is where you guys would get stuck. You're like, okay, so what do I do now? So the first thing I'm going to tell you is that because they're inverse functions, just like the square and the square root, the cube and the cube root, right? So I'm going to tell you this is what we would do. We would take the log base b of the x. If I do it to one side, I have to do it to the other. Not what I want to do. I want that in black. And since they're inverse functions of each other, what I'll have left on the left-hand side is going to be the log base b of x. And the right, because the base of the log and the base of the exponential function are both b, they're the same. What happens is that it just becomes y. So the number one thing we get out of this is this important information. If I take the log base b of b raised to the y, it's equal to y. Because again, log and exponential functions are inverse functions of each other, like square and square roots, right? Opposite operations. So we're going to show this one as well. That means if I take the b and raise it to the log base b of y, it's also going to equal to y. Again, they're opposite or inverse functions, so that's why that works. So that's kind of some key information that we're going to need to know, and I'm going to bring it back up a couple of times today. All right. But the thing that you guys got to understand is this. So if you look at this, this is a log function, just as well as this is a log function. These two mean the same thing. They can go back and forth. They're interchangeable. Oh, I'm sorry, not that one. What am I doing? Come on, Chan. You're better than this. I meant this one. There we go. Because the first one was an exponential function. So it's this one here. So then that means I can have the x is equal to b raised to the y. And I can also do log base b of x is equal to y. Or better yet, I should rewrite this on something I'm familiar with. So the only difference is that this would be the exponent form. And this here would be my log form. And of course, your question is, when do we use which one? Right? That's your ultimate question. So the thing of it is that we're going to have to know how to interchange them. And here's a couple of things that you're going to see on your homework. So let's say I'm given log base 7 of x is equal to 3. And I want you to change it to exponential form. What would that equal to? So if you guys look at where the x's are, the y's are, and the b is, how would that switch to the exponential form? Mm-hmm. Well, remember, the log is gone, right? When I go to the exponential form, there's no log in it. Not, well, the base is what? Well, what's the base, though? 7, so it'll be 7 to the third. So notice how if I was given this, I can actually find x, right? 7 to the third power, so it'll be 7 times 7 times 7. There you go, there's my x. So one of the things I was trying to remember back in college when I first learned log, because I was trying to remember, where everything goes. Because when you look at it, the only thing that is kind of the same on both is the base, right? Because in the exponent form, you look at the b is a base, right? And then on the log, it's also b is also the base. So that's the only thing that kind of stays consistent, but the xy switches. All right. So I remember this phrase just because I remember the phrase. It doesn't make any sense, but I just remember the phrase. So I always say the log base of the answer is equal to the power. Does that work? So let's take a look. Log base of the answer is equal to power. So convert that to the exponent form, where the base is the 7, right? The answer is x equal to x, and the power is 3, which is the power of that exponent form. Everybody see that? So this is the b. The answer was x. Oh, sorry. You know what? I'll just call this 7, because that is the base. And this is the 3. So 7 to the third is equal to x, which is my answer. Okay? Now, you guys can come up with anything you want, but that's how I remembered it. And that's what helped me kind of go back and forth. Okay? It might not work for you. You'd be like, what does that even mean? Log base answer equal power. All right? And I was trying to like pronounce it like an acronym, and it's like BAP. Lap interrupted by a B. I don't know. So, all right. So what if I'm given? What if I'm given b squared is equal to 25? What would that change to? To log form, of course. Look at it. log base 2, you think? Now I have everything written above, right? So it's going to be log, what's my base? B, right? What's my answer? 25 is equal to the power. Everybody see that? You're like, I'm not sure. All right, let's try another one. Given. If I was to convert to log form, yes. So log base 36 of 6 is equal to x. I want to do it to exponential form. Go ahead. Go ahead and say it again. I'm sorry. No. No. Go ahead. 6 is equal to 36 to the x power. Is that what you just said? I would say yes. So again, log base is 36, right? So the base is 36. Everybody see the 36? Answer is 6. Is it equal to 6? Equal to the power x. Is that power x? It is. All right. So here's a key point. If you look back to the original right here, guys, if you look back to the original right here, notice that the x and y is always like switched. Right, going from here to here is always switched. So when you said it was 36 to the 6 or 6 to the 36, it wouldn't work because it's on the same side. Right? The base is always the base. So when you look at here, when you see that the base is 36, you know that the base on the exponential has to be 36, period. Question is, what do I do with the x and the 6? Any questions? That's the only question that Will is willing to answer. Yes? Mm-hmm. What do you mean? Yes. Yes. Because if I use that, right, then when I write the log form, I'm looking for the base of the exponent form, the answer of the exponent form, and the power from the exponent form, right? When I convert from log to exponent, then I'm looking for it's something equal to a base raised to a power, so I'm looking at those pieces as well. Yes? Uh-huh. Wait a minute. You're given a totally different one. Let's put it down. Let's see what it says. Given, what did you want to give it? Log base 7. Uh-huh. 3 equals x. Okay. So what did you think it was? 7 to the x equals 3. Anybody else? No? So you think it's 3 equals 7 to the x? Can you guys tell me what's the difference between those two equations? No, nothing. They're just on different sides. Exactly the same. You are wrong. It's this way, the totally opposite way. So yes, that would be correct. No, method 1 and method 2 are both the same. Just to let you guys know.
So for the same thing for 36x, you can switch
to 36 raised to x is equal to 6? Yes. Because there's no difference. They're still equal to each other. Either way I look at it, I'm saying that 6 is equal to 36 raised to the x power. Or 36 raised to x power is equal to 6. So here's my question. On that one, what would be the answer? 36 raised to what power would give you 6? Whoa. So I'm looking at this one right now. What would be the answer? 36 raised to what power would give me 6? What's 1/2 known as? How about this? You are absolutely right. 1/2 is 0.5. So you could say 36 raised to 0.5 power is also 6. Absolutely correct. So, all right, let's think of other operations that not raising to a power. What do you do to a 36 to get 6? What's another way of doing it? Square root. Square root is the same thing as raising it to the 1/2 power. I don't know if you guys remember this in 1033 when I did it. Well, for ones that were in my class, I drew a nice sun. I drew grass, the birds, right? I said that the roots are under the ground, which is on the bottom of the fraction, right? And the power is above the grass because that is the sun that gives us power. Okay, good talk. So one of the things I said was, okay, so if I had, how do I do it? Let's do it this way. Let's say it's a cube root of x squared. Okay, the 3 is known as the root. And the 2 is known as the power. Right? So what I ended up doing was, what I ended up doing was I said, okay, so I had the grass, right? And then we had a nice tree. And of course, the tree always, and, you know, any tree that you guys see always has a hole in it. I don't know why. Right? There's always a hole in every tree that you guys see. Is that right? There's always a thick tree and there's always a hole in the middle. So where the grass is your fraction. Right? And of course, above the ground, I don't know why there's this yellow here. There's always the sun. Wow. Apparently our sun is getting worked on here. So there's a sun. So above the ground is where we get power because that's where the sun is. And below the ground is where the roots are, right? So that's where the roots grow. So essentially what we can do is write this as x raised to the 2/3 power. Because a 3 is a root, so it's below the ground or below the fraction line. And 2 is a power, so it's above the ground, right? So if I had the square root of x, or better yet, square root of 36, right? What's the power on that 36? It's to the 1st power. And what is the root since there's no number in the wedge? 2. So it's 36 raised to the 1/2 power. I guess you guys don't remember that in 1033. But I drew this, and the last in the fall I drew different, all my whole family. It was a diverse family. It was a yellow dude, a black dude, a red dude, a green dude, and then a never mind. And I do that / dude. All right. All right, so what happens if I was to write this instead? What's the question you have for me in this time? What's the base when nothing is written? Both. Well, why I say 1 and 0, both, I meant 10 is 1 and 0. So when no base, it is a base. Oops, wow. Apparently I'm trying to spell base with an E before the of 10. And this is called the common log. This is a point that I wish that I wasn't recording, because I'd be describing common logs way differently. Correct. If there's no base, it's a log of 10. Correct. And if you look on your calculator, I believe you have logs, but not log base something. And you have other things too that we're going to get into. So this is called a common log. All right, so let's convert this to exponential form. What would this convert to if the base is 10? Base is always the same. Here, I'll write down the base for you. 10. 10 raised to the x is equal to 100. Log base answer equals power, right? So the base is the base. Power is the power. Answer is the 100. So what would x equal to if this is the case? Yay. Oh, okay with that so far? Yeah. Okie dokie. All right, so a couple of other rules that you might want to know with logs. So I gave you one up here, right? Log base b of y raised to the y is y. B raised to log base b of y is also y. Well, here's another tidbit. It'll be log base b of b is going to equal to 1. And the log base b of 1 is going to equal to 0. So if you don't believe me that this is true, if we convert to exponential form, this would tell me that b raised to the first power is equal to b. Is that true? B raised to the first power is b. And this one says b raised to the 0 power is 1. Is that true? For some of you guys, you're like, 0? Isn't this supposed to equal 0? No, it's not. It's 1. We good with that? All right. So let's talk about the graph of it. So we're talking about the exponential function, which was y is equal to b raised to the x, and we're going to compare it to the log function, which we have two forms. We have x is equal to b raised to the y, or log base b to the x is equal to y. So let's talk about some of the characteristics of these functions on the graph. So intercepts. Actually, let's do it this way. So what was the exponential function? What was the intercept? It was a y-intercept. Where did it cross on the y-intercept? It crossed at 0, 1. Where would it cross in the log function? Okay, so let me repeat this. These are the things that you kind of got to catch. So I just said that the log function is the inverse function of the exponential function, yes? So I asked, how do we find the inverse of the exponential function, right? And what did you say? Switch to x and y. Awesome, let's switch to x and y. Everybody's like, I don't know. I don't know what the graph looks like. All right. It was, yeah. Math is very simple. So before I talk about domain and range, I'm going to show you the graph first, because I have on this list that I wrote down domain and range, and you're like, well, what does the graph look like? How am I going to know, right? So let's talk about the graph first. So we talked about, let's say, if b is greater than 1, okay? If b is greater than 1, what did the graph look like if b is greater than 1? You don't all have to answer at once. It's going from left to right. It's going to go up, and it's not going to cross the x-axis. Okay. So what would be the inverse of that? Let me draw some graph lines here. Let's use a different color. Let's use blue. What would that look like?
It's crossing the x, but it's going down.
And it's going to cross what point? And it's going to cross what point? 1, 0, right? It's going to cross 1, 0. Is that what you meant to say? It's like, you know, this.
It looks like that.
You know, like the way you just have it right there. Okay, what if, and then the other one was if b was between 0 and 1. What would that graph look like? We did it last class. It'll be decreasing. What do you think the log function would be if it was between 0 and 1, or if it's up? Yeah.
So from like the first quadrant, it's actually going to be like okay. So I guess like the first arrow is in the second quadrant, so it's going to flip.
It's going to flip a how? So is it going to stay like this? Okay. So I'm gonna look at your thing here. I'm gonna guess it's like this that you're saying. Yeah. And you're right. Because no matter how I look at it, it almost looks like that the b greater than 1 and the b between 0 and 1, it looks like it flips over the y-axis, right? And if you look at the blue, the log function, it flips over the x-axis, right? But you can look at the blue and the red, and if you look at the solid blue and solid red, it reflects over the y equals x axis, because we switch to x and y, right? So flip over that axis. And if you look at the blue dotted and the red dotted, it also flips over that, okay? But if you notice, going from left to right, the solid blue and red are both increasing as we go left to right. And the dotted blue and red are both decreasing as we go left and right, okay? All right, so now that we got that set, let's talk about the domain. Okay, so talk to me about domain of the exponential function. Negative infinity to positive infinity? Awesome. How about for the bleu? So positive infinity to negative infinity? Look at the graph. Look at the domain. Now point. Very, very close in reference to the infinity part. Because, aha. So this is going to get closer and closer to the y-axis, right? Which is x equals 0, but it doesn't cross or touch the y-axis, right? So my x value is going to get really, really close to 0, but not touch 0. So that's why the 0 here is in parentheses. Correct, because it doesn't actually touch the 0. Or the y-axis, I should call it. Does that make sense? Correct. That's why it would be asymptote. Yep. Let's talk about the range. What's the range of the exponential function? The range is all the y values. All the possible y values. But remember, you have to go least to greatest. So it'd be parentheses 0, comma, correct. And how about for the log function? Look at the arrows. Remember when I talked about range before? I said, look at the arrows, right? And then we're going to squish it so it only shows the y value. So the walls have to come in. if the wall comes in, what does this look like? The bottom is pointing towards what? Towards the bottom, which is negative infinity. And the top points towards the top. So it's going to be negative infinity to positive infinity. Oh, boy. Whew. You guys make me work for this. I need a raise. You guys act like you've never learned this before. You're like, this is the first time seeing this. This is such a surprise to me. When do we ever learn this stuff? Why didn't you teach us this stuff in 1033, Chan? Okay. How about the asymptotes or totes? One, huh? What is the asymptote for the exponential function? What does it go close to and really close to, but not touch? Y equals 0. Whew, good thing we got through that one. Whoa. Made me sweat. I really hope that because this is recording that I don't say anything wrong, because I can't go backwards, you know. I can't go, okay, I'm just going to delete this part right here. Or at least go back and go beep. All right, so last class, we ended with talking about natural numbers, and we talked about E, right? Remember that? We talked about E when like compound interest goes continuously, right? So we talked about the common log. We're now gonna talk about the natural log. Natural log. So if I had y is equal to log base E to the x, we wouldn't write this. This is known as the natural log of x. And if you look on your calculator, you have a log button and you also have a natural log button. You have both of those buttons. Do we find those buttons? You don't see the ln? The ln. So let's put all the properties here, comparing the natural log versus the regular logs the common logs or the general logs, all right? So one of the things we learned was that log base b of 1 is equal to 0. Well, the natural log of 1 is also equal to 0. We said the log base b of b is equal to 1. Well, the natural log of e is equal to 1. We said that the log base b of b raised to the x power would equal to x. Well, the natural log of e raised to the x will also be x. And we said that b raised to the log base b of x would equal to x. Well, e raised to the ln, or natural log of x, is also equal to x. Any questions? Now, so you guys might get things that, because shifting can still happen here, right? Still transformations can happen. Does that make sense? Yeah. So if I was to give you, so let's talk a little about transformation. So I want you to picture in your head, if you have to go back up here to the chart to see what the log graph looks like, right? Everybody see the log graph, the solid blue line there? So here's my question. How does this shift? Because the x shift is always the one that throws you guys off, right? So how does this shift? It's not on outside, it's with attached to the x. To the right 4 spaces. Okay? Remember the x always looks like it's kind of opposite, right? So it's going to shift right 4, right? Okay. So if it shifts right 4, what else shifts with it? So let me show you this graph here so you guys can see it. So if you take that graph, shift it right 4, what else shifts with it? The intercept shifts with it. So if I move that intercept 4 spaces to the right, where would it be now? Would it be 4, 0?
Oh, it would be
5, 0. Does that make sense? What else shifts with it? No. Well, the domain does shift, yes. Because obviously it's now no longer from 0 to infinity. Now it's going to be from 4 to infinity. But with that being said, that should help you with the answer. Because my question was pretty open-ended, right? So you could have said anything and it probably would have shifted. Excellent. The asymptote would have shifted, right? It was initially at x equals 0. So where would it be now? 4. Because from 0 move 4 spaces is 4.
Okay, so the intercept at 5, but then the asymptote itself is 4.
Yeah. And if you look at it, we always said that this asymptote here was x equals 0, and our point was 1, 0. Right? So it's going to move together. It's always going to be 1 apart. Right? All right? So that makes sense, guys? Okay. Is there any other questions? Nothing at all.